is the viability testing of the sperm and then hypoosmotic swelling test. So first one, that the viability testing. Viable, that means the alive sperm, and the non-viable, that is known as the dead sperm. So number of viable sperm is the most important sensor for the fertility capacity of the semen or the sperm. So most important sensor about the quality of the semen, the number of viable sperm is most important. Previously, it has been considered that number of the sperm is the important sensor for the fertility. But later on, it has been indicated that the number is not the only criteria for the fertility, because if the number is more than 20 into 10 to the power 6 per ml of the semen, but if the most of the sperms are dead, so there is no chance of fertility. So from this point of view, that means in assisted reproductive technology, so many sensors, that is sensitive sensors, are included for proper assessment of the quality of the sperm or the semen. Now, there are so many techniques for the assessment of the viability of the sperm, and out of these, eosin nigration technique is adopted. Eosin nigration technique is adopted. First one, what is the principle of the eosin nigration staining for the viability testing of the sperm? The principle is that eosin nigration staining is based on the integrity of the nuclear membrane of the sperm at the head point. Integrity of the nuclear membrane of the heads of the sperm. And if the integrity of the nuclear membrane is intact, is normal, then eosin, which is known as acidic stain, is unable to enter in the nucleus, as well as the cytoplasmic part of the sperm is unable to enter into the nucleoplasm. There is no chance of mixing between the cytoplasm and nucleoplasm. And so the head part of the sperm remain unstained, and that indicates the viable sperm. In contrast, when the nuclear membrane of the sperm is disintegrated, when the integrity of the nuclear membrane of the sperm is not maintained, it's intact framework, then from the cytoplasm, some fraction of the cytoplasm will be shifted to the nucleoplasm, and thereby the eosin can able to enter into the nucleus, and the nucleus would be stained, because the cytoplasm, which is the basic in nature, will enter into the nucleoplasm, and eosin can able to stain this basic part, and so the head part become red in color, which indicates the non-viable sperm, the dead sperm. So on the basis of the integrity of the nuclear membrane, the viability of the sperm can be assessed. So what is the principle of the eosin nigration? You may say that considering the integrity of the nuclear membrane's architecture, the viability of the sperm is assessed. If this architecture of this nuclear membrane remain intact, then it can able to separate the nucleoplasm from the cytoplasm part, and so there is no chance of the staining of the nucleoplasm of the sperm, and so the head part remain unstained, which is known as viable sperm. In contrast, if the structure of the nuclear membrane integrity is deviated from the normal one, if the architecture of the nuclear membrane is affected, then the cytoplasm would be shifted to the nucleoplasm, And as cytoplasm is basic in nature, so the eosine which is transferred to the nucleus can able to stain it, and the head part become red in color, which indicates the non-viable dead sperm. So this is the principle of the eosine nigrosin technique. Okay, nigrosin also gives the actually the background stain, and the eosine is the effective dye, and this eosine, which is known as this is the acidic dye, that can able to stain, that can able to color the basic part of the cell, and this basic part of the cell, that is the cytoplasm, where the different basic components are present. So this is the principle of this sperm viability. Now, what is the reference value of this sperm viability? Now, more than 75% of the sperm should be viable, should be unstained by using agrosystem. More than 75% of the sperm remain unstained. That means viable in type. That means they are not, their head part will never red color by using agrosystem. Then it indicates the quality of the sperm is very excellent, very good, is excellent category or very good category. Okay? And when it is less than 75%, 70%, 75% less, then the quality is gradually decreased. But when it is less than 60%, it indicates that the infertility is noted. So the viability, the sperm, the viable sperm count is the most important sensor of fertility, and as per ICMR reference value, that should be more than 75%. Then it indicates the excellent category of the sperm, excellent category of the semen. And 60 to 75% is the borderline. That means it indicates the semen quality or the sperm quality is good or standard, and there is no surety that the fertilization will be going on or not. But if it is less than 60%, it indicates that the sperm quality is not good. Okay. Now, next one, what are the reagents required for using agrosystem? First one, 1% eosine. Why? That is the yellow eosine. Why for yellow? 1% eosine Y solution is prepared in distilled water. That means 1 gram eosine Y is dissolved in 100 ml of distilled water. 100 ml of distilled water. And second reagent, that is the nigrosin, that is 10% nigrosin. That means 10 gram of nigrosin is dissolved in 100 ml of distilled water. So you first prepare 1% eosine Y in distilled water, and another 10% nigrosin in distilled water. Now, next one, what are the procedures, or what are the protocol, or what are the steps adopted? Now, before the steps, I like to mention what are the preconditioning to get the real, valid, accurate result for sperm viability. What are the preconditioning factors? What are the preconditioning factors that regulate, that influence the reliable results, valid result, accurate result, precise result? Okay. Number one, minimum 48 hours and maximum 5 days abstinence, sexual abstinence, or physical ejaculation, abstinence from sexual mating and others. Minimum 48 hours and maximum 5 days sexual abstinence is essential for good quality of viability result. Okay, number one. Number two, no contamination of semen with urine at the time of ejaculation is the most important factor. If there is any contamination of semen with any drop or fraction of urine, then the viability would be affected drastically. So this is the second condition. Third condition is that sterile container should be used for semen collection. Sterile container should be used for semen. Because if there is some infective agent or toxic substance, then viability will be affected drastically. Next one, polypropylene made container. Polypropylene made container should be used for this semen collection. Glass containers should be avoided because it also interferes the motility and to some extent the viability. Motility and some extent the viability. And last one, that is the re-liquefied semen should be used. Re-liquefied semen should be used for using agrocin testing. That means just after collection, if this semen is used for use in agrocin, it will not give the better result. Okay? And last one, that all the processes, all the steps in using agrocin staining process, then all the steps should be performed at 37 degrees centigrade. So temperature is the most important factor to maintain the viability of the sperm. If any deviation at the time of the procedural steps, which you adopt for such viability testing, less than 37 degree or more than 37 degrees centigrade, like 40 degree, 42 degree, or you may say 25, 26 degree, etc., then viability of the sperm would be affected. So these are the preconditioning factors. So if the question is coming that what are the preconditioning factors that should be maintained to minimize the experimental error, and to improve the reliability, accuracy, preciseness of your testing. Number one, minimum 48 hours and maximum 5 days sexual abstinence is the most important factor for good quality of viability result, number one. Number two, there is no possibility of contamination of urine with the semen. And if it is contaminated, then it also results the degradation of the viability outcome. Next one, that the container should be sterile in type. Container which is used for the semen collection as well as for the processing of the using agrocin staining, that should be sterile in type. Next one, polypropylene glycol made, polypropylene made tube or container should be used for these procedural steps, because glass made container interfere the motility and to some extent the viability. And next one, that semen should be re-liquefied before it's using in using agrocin staining technique. And last one, all the procedural steps of using agrocin should be performed at incubator within a temperature 37 degrees centigrade. So that temperature is strictly maintained. Okay. Now, what are the steps which are adopted? First one, that 1% using that you made are allowed to pre-warmed in incubator at 37 degrees centigrade. So the solution, using Y1% solution is pre-warmed at 37 degrees centigrade, okay, for 5 minutes to 10 minutes. Similarly, in agrocin solution, there is a 10% agrocin solution that you have already prepared, should be pre-warmed in a polypropylene made container at 37 degrees centigrade for 5 to 10 minutes. So both the reagents, both the solution that would be used for using agrocin staining technique should be pre-warmed at 37 degrees centigrade, number one. Number two, now the semen is collected in a sterile polypropylene made container, and it is allowed for incubation at 37 degrees centigrade for re-liquefaction, because after the liquefied semen first goes into the coagulation, and then by fibrinolysin reaction it will be re-liquefied, and that agglutination followed by re-liquefaction should be continued at 37 degrees centigrade within incubator. Okay, and that generally it is completed within 45 minutes to 1 hour. If there is any delay, then more than 1 hour is required, or it is not re-liquefied, then it indicates that there are several abnormalities of the semen. Okay, and that should not be used. Now next one. Now in another propylene container, polypropylene made container, suppose 50 microliter of the liquefied semen is added. 50 microliter of liquefied semen is added in a sterile polypropylene made container, and you add 100, that is 1:2:3. If 50 microliter semen, then you add 100 microliter using Y, okay, in that polypropylene container, and mix it and allow for incubation at 30 seconds. Allow for incubation at 30 seconds to 1 minute. 30 seconds to 1 minute. Next, now in that container, you add 150 microliter. That means the ratio semen is to eosin Y is to nigrosin would be 1:2:3. If it is 50, then eosin Y will be 100 and nigrosin would be 150. So you add 150 microliter of nigrosin to that same polypropylene made container and allow for incubation at 37 degrees centigrade for next 1 to 2 minutes. Okay. Now next step. Now after that, 10 microliter to 20 microliter. That means one drop, 10 to 20 microliter of reliquefied semen eosin nigrosin mixture that has been well mixed. That has been well mixed before. With gentle way, not in vigorous way. Okay? Otherwise viability would be affected. So 10 to 20 microliter of the premixed semen eosin and nigrosin solution is transferred on a sterile, clean glass slide, and a thin, homogeneous, uniform smear is prepared. A thin, homogeneous, uniform smear is prepared and is allowed to dry. At 37 degrees centigrade. Allowed to dry at 37 degrees centigrade. Okay, so 10 microliter or 20 microliter of the premixed semen using Y and nigrosin solution from that container is transferred on a clean, sterile glass slide. And these glass slides should be pre-warmed at 37 degrees centigrade. Mind that. It is not, it would not be at a cold temperature. That glass slide should be pre-warmed at 37 degrees centigrade. And then with the help of other glass slide is thin, uniform, homogeneous smear is prepared. Okay, and allowed to dry at within incubator at 37 degrees centigrade. Okay, now next one, after the full drying of this smear, it is allowed for scanning. Under bright field microscope. Okay, if there is phase contrast microscope, then it would be better. If it is not available, bright field microscope is sufficient for microscope scanning. Okay, next one. Then under each focal point, then under each field, you also count the number of viable sperm. That is a unstained sperm, unstained, and there is the non-viable sperm. That is the stained, that is the red color sperm. Okay, so you also select so many fields, like 8 fields or 10 fields or 15 fields, etc. So that the total number of sperm, that is the viable and non-viable. Viable, that means the unstained, and the unviable, that means the stained. So total number should be at least more than 100, 120, 150, etc. Okay. Now, then you compute what is the percentage of the viable sperm. That is the total number of the viable sperm, divided by total number of sperm. Total number of sperm, that means the viable plus non-viable. Okay, into 100. Non-viable into 100. Suppose out of 150, so 150 you have counted viable plus non-viable 150. Out of 150, your viable sperm, that is the unstained sperm, is about 120. So the percentage will be 120 divided by 150 into 100. And if this level is near about 75% or more than 75%, then it indicates that it is excellent category of semen. Excellent category of the sperm reserve from the viewpoint of viability. From the viewpoint of viability, not from other sense. That is not from the viewpoint of actosome, not only from the viewpoint of motility, not only viewpoint of the morphology, but also from the viewpoint of that is the viability. Okay, and they say this is the excellent category of the sperm reserve. And if this percentage, if this value is less than 75% up to 60%, you may say that is the standards. Okay, that means you can able to separate the good quality of the semen by swim-up technique that I've already mentioned in art, assisted reproductive technology. Okay, or by Parkol gradient. By Parkol gradient, you can able to collect the super great quality of the sperm by swim-up technique or by Parkol gradient. But if in this count is 75% or more than 75%, then such separation, such swim-up technique or Parkol gradient separation technique are not required for the collection of super great quality of the sperm. Okay. So this is the protocol of the use in nitrogen staining. And what is the explanation of this technique? I have already mentioned that this technique actually signify the architecture of the nuclear membrane of the sperm. If this architecture is normal or intact, if the meshwork of the lipid, protein, along with carbohydrate structure of the nuclear membrane is intact, then this membrane can able to separate the cytoplasmic compartment from the nucleoplasmic compartment. And thereby, the eosin, which is added, can able to bind with the cytoplasmic, that is the basic part. Okay, but it is unable to stay in the nucleoplasm, okay, which is acidic in nature, because eosin is already acidic, so acidic part is unable to stay in the acidic part. And so, if the nuclear membrane remain intact, then it indicates, you know, the nucleus is the brain of the cell, so the cells are remain in high active status, and that is the viable sperm, and that is the unstained sperm. But if this nuclear membrane integrity is destroyed, if this architecture of the nuclear membrane is affected drastically, then there is a chance of mixing. Of the cytoplasm with the nucleoplasm, and thereby the eosin, which comes to the nucleus, can able to stay in it, because the cytoplasm has already shifted from the non-genomic compartment to the genomic compartment, and thereby the head part of the sperm becomes stained, and this indicates the non-viable sperm. So this is the explanation of the eosin nitrogen staining of the sperm to diagnose, to test the viability, okay, which is the important sensor of the fertility. Now, next technique is the HOS test, HOS, that is the hypoosmotic swelling test. This indicates the integrity of the plasma membrane. Mind that viability indicates the integrity of the nuclear membrane, but here the hypoosmotic swelling test indicates the integrity of the plasma membrane. And you know that the tail part, the tail length of the sperm is about 90% of the total length of the sperm. 90% of the total length. Because you know that length of the sperm is about 50 micron, 50 micron. And the length of the tail is about 45 micron, 45. So it covered the 90% of the total length of the sperm. And thereby, the plasma membrane surface area at the tail part is maximum in respect to the body part or neck part or the head part of the sperm. Okay? Now, in hypoosmotic swelling test, the sperms are allowed to fix or allowed to embed in a hypoosmotic solution. Hypoosmotic, that means where the osmolality is less than the cytoplasmic osmolality of the sperm. So the sperm are placed in a solution, okay, or incubated in a solution, okay, which have low osmolality, which have hypo means low, which have low osmolarity in respect to the cytoplasmic osmolarity of the sperm. Okay, and due to such embedding and due to such actually culturing of the sperm in hypoosmotic swelling, hypoosmotic solution, okay, fluid would be shifted because in hypoosmotic solution, fluid concentration, there is the water concentration maximum. So fluid would be shifted from this hypoosmotic part to the cellular part, the sperm, and thereby the swelling is noted, mainly at the tail part, because the tail part, the plasma membrane surface area at the tail part is maximum in respect to the head, neck, and the body part. So there is a swelling of the tail part. The tail part would be bent, something bent, sometimes bent, so it would be swollen in. So if it is swollen in time, okay, then it indicates that plasma membrane integrity is okay. Plasma membrane integrity is fine. Plasma membrane integrity is fine because here the hypoosmotic solution can able to allow to transfer the fluid from this hypoosmotic part to the cellular part. But if the plasma membrane integrity is affected drastically, then the inward and outward fluid diffusion will be going on. Fluid input and output will be going on. And so there is no change. There is no change in the shape of the tail part of the sperm, which have maximum surface area of the plasma membrane, which have maximum surface area of the plasma. Am I clear? So hypoosmotic swelling test, the principle is that we can, through this test, we signify the integrity of the plasma membrane of the sperm, and as the tail part of the plasma membrane, tail part of the sperm occupy the maximum surface area of the plasma membrane of the sperm. So the placing of the sperm in the hypoosmotic solution, fluid will be shifted from the external hypoosmotic solution to the interior of the cell, and so this tail part will be swollen, and it may be bent in structure, which indicates that the sperm membrane integrity, plasma membrane integrity is okay, it is fine, it is standard. But if such placement of the sperm never change the shape of the tail, then indicates that the architecture of the plasma membrane is not maintained, and thereby these sperms are not suitable to conduct the fertility. Why? Because you know that sperm membrane contains so many enzymes for their motility, for energy production, for their viability, for their fertility, okay, for their capacitation also. Now, what is the reference value? The reference value is that more than 60% of the sperm, more than 60% of the sperm will show positive result in hypoosmotic swelling test. That means more than 60% of sperm where the tail part would be swollen, tail part would be bent. Then it indicates that there is a good quality of the sperm, good quality of the semen. But if their number is less than 60%, then indicates that there is some question about that quality from the viewpoint of fertility. Now, what are the reagents? Next one. 0.735 gram of sodium citrate. Sodium citrate, that is Na3C6H5O7 twice is 2. I repeat it. Sodium citrate Na3C6H5O7 twice is 2. So 0.735 gram sodium citrate and 1.351 gram of fructose dissolved in 100 ml of distilled water. I repeat it. 0.735 gram of sodium citrate and 1.351 gram of fructose dissolved in 100 ml of distilled water. Next, 1 ml of this aligot is allowed to freeze, okay, or allowed to actually freeze at -20 degrees centigrade. And at the time of the testing, each aligot is collected from this freezer and used for such testing. That means at the day of the testing, it is not necessary to prepare the reagent. It may be prepared before, and it should be freezed at -20 degrees centigrade at 1 ml aligot individual, so that on the basis of the number of the sample, you can able to collect the number of the vial. In each vial, 1 ml aliquot is freezed, 1 ml aliquot is freezed. Okay. Now next one, what are the procedure? Next one, first that 1 ml aliquot, that 1 ml vial is collected from the refrigerator and it is allowed to warm up at room temperature at first and then at 37, warm up at 37 degrees centigrade. Okay, and that should be maintained. That incubation at 37 degrees centigrade must be continuing for 5 to 10 minutes. So first one, 1 ml vial containing sodium citrate and fructose solution are transferred from the refrigerator to room temperature, and after 30 minutes, okay, these are transferred to an incubator at 37 degrees centigrade, 37 degrees centigrade for 5 to 10 minutes. Okay. Next one, semen that is collected allow for coagulation and reliquefaction at 37 degrees centigrade, and 0.1 ml of reliquefied semen is allowed to mix with that 1 ml containing sodium citrate and fructose solution, having the osmolality is less than cytoplasmic osmolality of the sperm, less than cytoplasmic osmolality of the sperm. Okay. And next one, this incubation, that means the 0.1 ml of reliquefied semen with 1 ml aliquot is allowed for incubation at 37 degrees centigrade for 30 minutes. For 30 minutes. And at the time of this incubation, if the plasma membrane integrity is okay, then the fluid would be shifted from the hypoosmotic solution to the cytoplasm of the sperm, and the tail part of the sperm would be swollen. But if this membrane integrity is not maintained, there is input and output of the solution or the water, and the tail part would not be swollen. So after 30 minutes, what we will do? Next step, that 1 or 2 drops of this mixed solution is transferred to a glass slide, and then you also prepare a smear, okay, and it is allowed for microscope scanning. Next one, what is the observation? Observation that in each field you also count the number of sperm with swollen tail and number of sperm with unswollen tail. So swollen tail and unswollen tail, okay? And then you also quantify that what is the percentage. Percentage, there is a HOS positive sperm. That means number of swollen sperm divided by total number of the sperm counted, that is swollen and unswollen, into 100. Suppose you count 150 sperm, swollen plus unswollen 150. Out of 150, 120 are swollen. So the HOS positive sperm, 120 by 150. If this count is more than 60%, it indicates the quality of the sperm is good from the viewpoint of plasma membrane. And if it is less than 60, then the quality of the sperm is not very good. Why plasma membrane is very much important for fertility? Because you know that along this plasma membrane, there are so many enzymes present. Like ATPase enzyme is also present, which is responsible for motility of the sperm. And you know that motility of the sperm is very much essential for fertility, because the movement of the sperm is required. That is controlled by this modality. And this is also under the guidance of ATPase enzyme, and that ATPase is also attached to that plasma membrane. Okay. Similarly, the electrical potential maintenance, that is the resting potential to action potential, there is a depolarization. Okay. That also depends on the defined protein present in the membrane, which are known as the gate protein, voltage gate protein. Okay. Gate protein, ion channels, these are also protein in nature. So if this membrane integrity is affected, then ion channels, then the ion gate proteins are destroyed. And due to such destruction, sodium and potassium efflux would not be maintained. And thereby the depolarization of the plasma membrane of the sperm is affected. And that interferes their motility, that interferes their cytological activity, that interferes their capacitation process, and thereby the fertility is also affected. So from such viewpoint, the membrane integrity assessment, membrane integrity examination is very much essential, and that can be performed by HOS test. Okay, so this is all about, that is the viability testing and the HOS testing. Okay. What are the other remedial parts? What are the other residual parts in your syllabus that was not covered? If any part in that paper remain untouched, okay, please send me the topic through WhatsApp. Huh? In that paper, that is a reproduction and assisted reproductive technology, which part have not covered till now, you also inform me through WhatsApp. Okay?
Okay, sir.
Yes, sir.
Then the next class, I like to arrange that class, which was remain untouched till now. Okay?
Okay, sir.
Is there any question about that viability and HOS testing? Is there any question? Have you any question? Have you any question? HOS testing and viability testing.
Sir, এখানে HOS টেস্টের ওই সেকেন্ড মানে প্রসিডিউরের সেকেন্ড পার্টটা স্যার বলুন, ওই এলিগটের